Alrighty, I'm back, Calculates. This is going to be a new program that I'm going to try out for a little while. It's called Camtasia, and I'm going to see how it works out. Alright, so I gave you the 6 trig values in the last one, as well as your power rule and your log rule, and these are your brand new, spanking new formulas. You need to talk about these with the people on your teams and decide what are some strategies that you have to help you memorize these. And I would like to tell you that they're only going to test you on one or the other, but we don't know which one. So you kind of sort of need to know both of them. I know that's a drag, but in a multiple choice, they could give you either version. Okay, so now moving on, we would like to be able to use these in our problems. So when I look at the first one, up till now I've not had a strategy, of course, for finding the antiderivative when I have a fraction and there's something on bottom. So now I'm going to use these new log rules. And I say, all right, let's let u be the denominator. And then, of course, du is going to be 1 dx. And, of course, I hope I have that. So I check to see if I have this anywhere. And, of course, I do. And so now I can rewrite this as 1 over u du. And now I know that the antiderivative for that is natural log of the absolute value of u. Don't forget your vitamin C. And then I can plug back in. So I get natural log of x minus 5 plus c. So on the next one, same issue. I have a denominator. So I'm going to try letting u be that denominator. Remember, u substitution, there's nothing really magical about how to make sure I pick the right u substitution anytime. Sometimes you just have to try it and see. And also think ahead a little bit about what's going to happen when you take the derivative. So for example, on this one, when I take the derivative, oh my gosh, I'm going to end up with an x squared, which is good because, of course, I have an x squared and a dx up here in the numerator. So it looks like it's just missing a negative 3, so fine, I'll put a negative 3 in there. And remember, I have to compensate out in front, so out in front I'll have a negative 1/3. So now I have negative 1/3, 1 over u, and now all of this stuff gets absorbed and turned into a du. And so when I take the antiderivative, I get natural log of absolute value of u. Remember, we have to absolute value it because you can't take a logarithm of negative numbers. So I always have to make sure I absolute value them. And then substituting back in, that'll be 3 minus x cubed plus c. Awesome. Moving on to problem 3. So again, I see some stuff underneath a radical and it's in the bottom. So I'm going to try the stuff under the radical first. See what happens with that. Because that's going to allow me to have over square root of u, which of course will turn into u to the negative 1/2. I can deal with that. And then when I take the derivative, I get negative 2x. And then I say, sweet. I have the x and the dx. Got it, got it. I just need a negative 2, and I'll have to compensate with a negative 1/2. So now I'll have the negative 1/2 outside, and all of this numerator will turn into du. And if I like, I can write it as u to the negative 1/2. So I'm ready to power up. So power back up, I'll have u to the positive 1/2. And of course divide by 1/2 or times by 2. And I already had that negative 1/2 down there. And some magic happens, those cancel. And so I get negative u to the 1/2 plus c, or negative 9 minus x squared to the 1/2. If I like that, I can put it back in the radical. Plus c. Awesome. Let's try number 4. Again, gonna let u equal that big scary denominator. See what happens. And if I take the derivative, I'll get 2x plus 6. And I want to know how close that's going to be to the other stuff that I have. So if I look at all that other stuff, I go, well, okay, cool. So I've got the dx, of course. Well, how close is x plus 3 to what I have here? And I go, oh, wait. I can create an x plus 3 out of this. No problemo. So it's going to need a 2, which means I'll have to compensate with a 1/2. So now all of that is going to turn into my du, so I'll have 1/2, and I'll have a du, and remember all of this bottom was getting a u substitution. And so the antiderivative of 1 over u is, again, natural log of u. Gosh, Torres, you're so boring. Keep giving us the same problem over and over again. And substituting back in, I'll have natural log of x squared plus 6x plus 7, all in the absolute value, plus c. Okay, c. Let's try another one. So let's see, I do see something powered up. That was kind of one of my rules before, right? So let's try u equals x minus 1, which means du is 1. So now I'll have x minus 2, got the dx still there. Oh, oops, I forgot the dx. Over u cubed. So got rid of that mess on bottom. But I have all these x's on top. So let's see what x is. I wonder what x is. So if I solve for x equals u plus 1. So this is going to turn into a u plus 1. And this is going to turn into a u plus 1. And so now that's all going to look like u. So plugging that in, of course, I get u plus 1 and u minus 1 all over u cubed. And now du and dx are the same thing, so I can substitute it. And then that top, of course, I could multiply that out. Nice and easy. And now I can split the fraction. So I'll have u squared over u cubed minus 1 over u cubed. And I bet you don't even need me to help you do the rest of that. So pause the video and try it yourself. Okay, so you should have then simplified it, right? And of course that first piece is going to be natural log of u. And then I'm going to power up. So I'll have u to the negative 2 over negative 2. So that's going to turn into a positive. Plus my c. And then when I substitute back in, remember u was x minus 1. So I'll have natural log of x minus 1 plus 1 over 2 times x minus 1 squared. That's a negative, so I was just taking it down. Plus c. Looks complicated. It's not really. Let's try another one.